All right. So this was a talk I gave recently at like a local hardware or local kind of hacking event, and it was based on a conversation I had basically with a guy while I was doing this work, my buddy Chris, in a kind of a chat, and I was explaining what I was doing and stuff, and he's like, "Man, that sounds pretty sweet. Like, you should do a talk on that." And I was like, I don't want to do all the stuff. And so he summarized it real quick, like what we had talked about. And I was like, well, okay, I guess you kind of did the work there. So I created some slides, and this is what it is. And it's about basically a day and a half. I was vibe coding this tool, and I was chatting with him about it while it was going, and the experience of doing that, and kind of how it opened my eyes a little bit to some of this stuff. There's been a couple things that AI really opened my eyes, and this was one of them. So I'm a hardware guy, basically, like at my core. If you watch my YouTube channel, you'll see a lot of it's kind of hardware related. There's a lot of hardware stuff that's all around here, and so I'm not as comfortable with software. If it's embedded software, if it's bare metal kind of stuff, if I have full control of the system, I'm a little more comfortable that I have a feel of what's going on in the thing. But as it gets bigger, I just lose myself in the abstraction and all the stuff you're supposed to do, I guess, to create software, which is all these words that are over here on the side, like boilerplate and callbacks, and this stuff just makes me lose my mind. And so I generally kind of, if I can solve the problem with hardware, I solve it with hardware, and I don't go the software route. So, but the challenge is there's just stuff I need to analyze. Like you can't just stay in the hardware domain forever. And so I'll capture signals like you see on the oscilloscope right there, and I need to do stuff with them. I want to compare them. I want to see how they change over time. That yellow one there is actually a measurement of the voltage of a chip while it's running. So the little kind of blue line at the bottom, near the bottom there, is when it's reset. And so you see kind of the voltage fluctuations in that chip. And I want to try different things as I reset it. I want to compare these signals, the yellow trace, and see what happens as I make changes. And so doing signal analysis, filtering, all these kinds of things. My scope doesn't cover that. It does some of it. It'll do an FFT, but I need to get it out of the scope and into the software domain and do things with it. But like I said, I know conceptually what I want to do. But where do I start? What files do I create? Where am I supposed to put things? What's all the stuff you're supposed to have in there? How's everything linked together? I just find myself wandering my neighborhood like this guy, and I'm staring at the trees and the birds, and I'm like, why can't I figure this out? And it just drives me crazy. And so I don't end up creating the software. Whatever it is, sometimes I do, but I really got to push myself to do it. And yeah, so that's really, that's my challenge. Everybody's got our own challenges, I guess. But this stuff just sends me into a tailspin. But that's not to say that I don't create software. So about 3 years ago, I have a video on my YouTube channel called Glitchy, or it's about this program I created called Glitchy. And this is a program that I wrote myself 100%. So I learned everything about, how to create a kind of a GUI application, how I should structure it, model view controller frameworks, and so where you should put things, where should the UI code live and what files, and where should the logic live, and where should your data structures live, and then how do you even create a GUI front end, and what framework should I use for that, and all this kind of stuff. And so I spent a good amount of time doing this, and by good amount of time, I mean my first commit was September 18th, and the last one was around November 20th or whatever you see here. So two months of working to try to create this program, which basically tried to make it easier for me to glitch parts. So as opposed to writing all the code that you would need to set up these kind of processor glitching systems, I wanted to basically kind of take it to more of an abstract level where I say, well, I'm trying to do this, I'm trying to start here and whatever, and I don't want to stare at code. I want to look at it in a more visual, graphical kind of representation. So it's like I say, 2 months, and the first commit happened probably after a good amount of time working on it too. So it's not like I started September 18th. I must have started some amount of time before that, writing whatever it is that got submitted then. And so after spending basically 2 months or more writing this tool, I kind of found out like, well, actually, I don't really think that's that hot of a way of doing it. Like, I mean, it's nice, but the problem is when you're glitching, every setup is almost unique. And so you kind of quickly realize, like, I'm just going to be working on this tool forever. And so what the hell's the point of the tool? And it's not like I'm fast at doing it, right? So I'm going to be working on this tool for some period of time, you know, not indefinitely, but maybe a lot, right? It's not just going to be this thing I write and it's all great. So it just kind of ends up like abandonware, right? You know, it's out there, but you know, I find myself, I don't use it, and it, I would say it would have solved a cool problem, but it just took too long. And so knowing that and that experience, you know, I'm like, well, do I want to write another thing like to learn all the GUI framework and a tool to help me do whatever? And so the answer is kind of no. But the difference with basically vibe coding now is that this tool that you see kind of over here on the left hand side that's allowing me to do signal analysis took me 2 days, really a day and a half. From the idea, like the concept of I'd like to be able to pull traces from my oscilloscope and then do low pass filtering, high pass filtering, FFTs, compare multiple traces, all of that whole everything there in a day and a half, just coming up with the features as I was doing it. And so, you know, it's kind of like, well, how, you know, and that's more than an order of magnitude. You know, it's 1.5 kind of orders of magnitude improvement over what I was doing before. So in a day and a half, hell yeah, I'll spend a day and a half to get a tool that solves a problem. And I've used this tool way more than I used the tool that I wrote myself, because it's like I had the idea for the problem, I did it, and I've been using the tool, and it's been working great for me. And so, you know, what makes that possible? And for me, it was Claude Code, and there's a lot of other ones out there. You know, I'm sure you can look at, but Claude Code is one that I used, and it worked pretty well. Just check the questions over here. How's it going, everybody? 77.7 subscribers. That's awesome. Next smart meter episode, I'm not sure. I'll be working on another, a different one about kind of different inspection techniques, but I'll show probably some smart meter stuff in there. So we got to enter the vibe zone. So the vibe zone, what I've discovered is you kind of stay in the abstract and you apply domain-specific knowledge, I would say. So it's not that I don't know how to program. Like, I know how to program. I just feel horrible while I'm doing it and completely lost most of the time. But I know how to do it. I can look at code. I can fix bugs. If I have someone else's program, I can figure out generally if I want to tweak it, how to do that. But what this does allow you to do is iterate incredibly fast. Like if I wanted to make a change to my glitchy program I wrote, I mean, I'd think long and hard, right? It's like, do I really want to change the UI? I'm married to it at this point. Like so much effort and time went into all the stuff of where I'm spacing everything and all this, that it's like someone could suggest something way better and I'd probably be like, wow, you know, this is good enough, right? Where when you're vibe coding, you're like, screw it, just blow the whole thing up and start again. But you do have to learn the strengths and weaknesses of whatever tool you're using. And so just like any tool, these kind of AI tools are similar. You have to figure out what they're doing. And so just to kind of zoom in on this, the stuff that I'm wanting to analyze, at least at this point when I created this, is that yellow signal you see there. So that's a differential probe that's hooked up to a board. Let me see if I can show you here real quick. It's a differential probe that's hooked up to a board. All right, check this out. You're in here now. Well, there's my presentation. Here's all this stuff. Here's this little differential probe. So it's measuring the voltage of this chip, and it's showing it here on the oscilloscope as the yellow trace, and I got my little power supply down there. So that's what I'm looking at there. I'm looking at the power utilization of this chip that's running, and I want to suck it out of there and do something with it. So that yellow trace is basically the blue one that we see up top here. Get some coffee fuel. So this is the program itself, and 100% this thing was vibe coded. Everything about this program. It's not like I created the UI or I built the front end and then I populated it. It connects over the API for the Siglent oscilloscope to pull this trace. It did all that writing too. I mean, I didn't look at the code for this thing the entire time. Other than what it shows in Claude code when you're doing it, I wasn't in GitHub looking at it or anything like that. I literally vibe coded this entire thing all the way through to using it, and I hadn't looked at the code whatsoever. I actually looked at it just a little bit earlier today because I want to show you something a little later about it that you can see. Also, if you are a Patreon and you go over to the Rechesam page, you will see this. So if you're a Rechesam Patreon, you go here. For any of my the top tier Patreons, I posted in there this code. It's not public on my GitHub right now, but if you're a Patreon, you can go over here if you're interested in seeing it, if you want to use the tool, if you want to play around with it, if you want to stare at vibe coded stuff, you can check it out. That went live, I think, at noon today. So this is the program. It pulls in that signal, which you see. Basically, I come up here at the top here and I click this capture button, and depending on if I've selected channels 1 through 4, that's 1 through 4 on the oscilloscope. When I click capture, it brings it across, and if I click capture again up to 10 times, it'll bring 10 different traces in, so I can basically kind of power the chip up, grab a trace, reboot it, grab a trace, reboot it, grab a trace. And so then I can compare those. If I've, say, changed some flags in the chip, I've changed some value that might lock it or unlock it or whatever, I can look at these power traces and check them out. And so when I say power trace, what I mean is that this is basically the current consumption of the processor. And so when a chip's running, everything it does, this is like hooking up a whole kind of crazy EKG machine to a human, right? Where you just see everything that their body is doing, a lie detector or something. This is similar. When you hook this probe up to a chip that's running properly through like a shunt resistor, you end up seeing all the fluctuations, and those fluctuations are everything it does. Anything the chip does, you're going to see reflected in this power trace from every time it runs a piece of code, every instruction it runs, if it uses some internal peripheral, turns it on, off, all those things take power. And so looking at this lets you see that. And so one of the cool things you can do is you can filter it. So the same way you can do a filter on an audio signal or anything else, you can filter this. And so if you do a low pass filter on it, you go from this, lot of noise, and you can see like there's interesting signals in there. There's things that are happening, but like I don't need all the noise. I want to see kind of the bigger things that are happening, different system accesses, flash memory, writing to SRAM, things like that. So when I filter it, all of a sudden, well, there's a lot less that you have to deal with, right? And there's some pretty interesting things to look at. And all of those things are potential attack points. And so that was the primary reason I created this tool. My oscilloscope doesn't allow any filtering on it. It'll do the FFT, but not the filtering. And if you have one of these really high-end oscilloscopes, then a lot of times they have features like this. But I have what I have, And it's also cool just to be able to do it through software, because then anytime you dream up some new analysis, you don't have to worry about whether your oscilloscope supports it or not. The other piece I thought I'd bring in is an FFT analysis, and so this lets you see the frequency components of that wave you've grabbed. So all the kind of anything that's repetitive, whether it's a clock signal that kind of makes itself visible in fluctuations in the voltage, you can see all this stuff when you look at the FFT signal. And so I also wanted to be able to have that show and be reflected as I'm doing analysis. And then the other couple pieces of the interface you see is there's obviously the ability to connect to an oscilloscope to apply the filtering, to save this data. So when I get the capture data, I can save it, I can open it up, pull new stuff in so that I can take measurements and have them for later. And then I was playing with adding some statistics over here. It wasn't the primary goal of the program, so I think some of them are kind of on, some of them are off a little bit, but I wanted to see, could I add some extra boxes there? Could I populate some data in there? And so like I say, everything about this was just me telling Claude, like, oh, I want a new area called filter controls. I want to do low pass and high pass filtering. Can you auto suggest filters? That is that's still alpha-ish, because figuring out what values to put in for the filters, there's definitely mathematical ways to do it, but I was literally not doing any of that research. I was just telling Claude, like, hey, come up with a good way. And so it has not come up with a good way yet, but it's trying, bless its heart. The other thing I would say is that connecting to this oscilloscope, the API that was used, at first I asked Claude, I just said, hey, I have a Siglent SDS, whatever, 2104X plus. Go get the API document and figure out how to connect to it. And so it did, and it did connect to it, and it pulled in the data. But if we look here, when you see it shows the voltage on the side over there and the time in microseconds, the voltage wasn't correct. And so there was some transformation that needed to happen with the data that came across to get the correct voltage. And so I would tell Claude, I would be like, hey, you're saying it's going from minus 5 volts to 10 volts, and it's actually going from minus 0.5 to 0.1. And so then it would be like, oh yeah, you're absolutely right, because that's what Claude tells you every time you tell Claude anything. It's like, man, that's great, I'm absolutely right. But then it tried to fit the data to the voltage. So it's like, okay, I changed the multiplier value so that now it's pretty close to the range you said. And so I'm going back and forth with Claude, and I'm like, buddy, we're doing engineering here. Like, it's not pretty close. I need you to make it exactly what it is on the oscilloscope. And that was like, I got lost in like a tailspin with it, because it falls apart at that point. So at that point I stopped. I went and searched on the internet. I found the proper API document, because apparently Siglent is just like, which scope uses what document has no relation to the part number that's on the thing and the part number that's in the document. So they must be updating stuff but not updating their documentation. I'm sure that's everybody. And so once I found the right document, I copied the code out and I said, you need to implement it like this. Talking to Claude. Boom, no problem. All done. And it worked fine, and it comes across. But there are things like that where you can spin your wheels a lot, and spinning your wheels turns into money you're spending using Claude. So you do have to pay attention to some of these things and help it where it probably needs the help, and then you can use it the other way. Now, let's talk about kind of some tips and tricks for this thing. When I was doing it, I created the program as it's just one file. Like, it started as like signalanalyzer.py when I began. And it was just like, try to connect to the scope, try to pull one trace and use matplotlib or whatever to show it on the screen. And so quickly I realized, like, that's not going to work. Like, I need more stuff. But the file kept getting bigger and bigger and bigger and bigger. And so I'm laying in bed one night, and I thought, well, I'll just ask the other Claude, not Claude Code, what the heck I should do to break this thing apart. And so I ask it, and it's like, hey, you're absolutely right, and it told me all the stuff about how to break it apart and the proper techniques and blah, blah, blah. and it showed here's how you should structure it, and then it's model view controller pattern. I thought, oh, I know about model view controller. Like, all this makes 100% sense. So I had to do that. I literally had Claude write me the prompt that I take to Claude Code to, basically break everything apart and make it so it's going to be so much better and more maintainable and all this crap. And the reality is, it just literally Claude choked to death on all of these different files that it created and documented for itself of how it should structure the thing. It just did so much better when all I had was one file. Because as the context of the software grows, what I realized is that quickly the size of your program gets to the point where it doesn't fit in Claude's context window anymore. So Claude can't just load the whole Python file in and look at it and do stuff. It ends up like grep searching it for what it thinks might be the functions that you're talking about, because depending on how much context you have loaded, it might not even remember that unless you've documented in a Claude MD file where this stuff is. So it just like it works way better if it's just one file versus all these files. Because with all the files, what it started doing is like it would search for a while, it couldn't find what it was thinking it needed. I didn't know if what it needed was there or not. And so it just kept creating new functions all over the damn place. It didn't respect model view controller whatsoever. And so I just realized, like, okay, even though everything that you ever see or read anywhere says one big file is terrible, like working with Claude to create these kind of tools I need, one big file, I got way, way better results. Now, like I say, this is all anecdotal. I'm not a software developer. I'm a guy that used Claude to create this tool. And so this is kind of my experience doing it. And the few times that I've done it, one file has vastly outperformed the multiple files. Now, I would say feature creep is definitely a real thing. So when you can iterate incredibly fast, every time you have an idea, you're just kind of like, what the hell, Claude? Let's give this a shot. Let's add this here. Let's add that there. And like I say, it's not free. Like, you're using API credits, or you're using your Claude account, and maybe it gets locked out over time or whatever. And so you can just kind of keep iterating and trying things, and you might not really be making progress towards whatever it is you're trying to develop. And you can break stuff along the way too, obviously, depending on how disciplined you are with what you're doing. So what I realized partway through my signal analyzer program is, like, I kind of stopped and I was like, well, what am I trying to solve? Like, what's my goal here? And let's solve that problem. And then if I want to do something else or whatever, I'll spin it off to something different or whatever. But I kind of stumbled into that because, like I say, it was so easy to do anything I wanted. Like, you're talking about minutes to making a change, that I'm just in there, like, I guess vibing, right? Like, in there, vibing, adding features. So let me show you real quick. Let's see here. Here's a Ubuntu box. Here's the software. Let me just open it up real quick here. So here it is when I run it. Now, the cool thing is, if you have access to it over on Patreon, I created in the oscilloscope driver a mock driver. So you don't even have to have a Siglin oscilloscope or whatever to play with this thing and check it out. So when it starts with this mock driver. You don't have to worry about, this IP address or anything. If I just click capture, it grabs what we're looking at in the video. And then if I want to apply a filter, like, it saves this data when I closed, so it has 6E6. You can enter it, scientifically, or I can say 6 million, and I apply my low pass filter. There we go. I had it, like, everything here is vibed, right? I had it. Okay, I want to be able to zoom. Now, what you see too is that I realized that some of these traces can be big, 10 million points, 100 million points. So I actually had it decimate the data. So I explained to it the problem, and I said, I want you to decimate the data that I'm looking at on the screen, so that when it's zoomed all the way out, it's not going to show, the full 10 million points, so that my little hover over action here works. And you see kind of down here, that changes as I'm hovering to show me what the voltage is. And so yeah, so all that stuff updates much faster than when it had 10 million points and everything was slow. So this was kind of, these features were iterated as well. And so if I click capture again, what you see is it changes now. So now down here in the display, and like I say, all this stuff was just me telling it how I wanted to add it in. It brings in the trace. So we can see, compared to the prior trace, right? So these are both the exact same trace. Different if I was doing it on the oscilloscope, they'd be a little bit maybe time shifted or whatever. But you can see how, okay, cool, this low pass filtering is pretty sweet. How it's like, this doesn't really seem to be a thing, but this does seem to be a thing. And then you can, turn off different ones you want to have on. You can change which one is the primary one. So, which one's going to show on top out of all of them. So if you're capturing multiple traces, you want to see have things shifted, are peaks different. You want to do like I did here and low pass filter them. If I apply the filter again, it'll do it to both of them now. Yeah, you can do all that stuff. And all of this was done through the vibe coding. Now here, if you pick a different channel, it's just going to pull the same data in because I didn't capture and save data for each channel. I only did it for channel one. But yeah, that's the tool, and that's kind of what I'm trying to solve with it there. So like I say, these where is it? These things, all this stuff is where the feature creep kind of started coming, and then also saving the data. Like I grabbed one trace. If I grab two traces, it'll save both of those into the save file. And so every time you add something, it's like you have to then test everything else. And of course, everything else is broken because Claude doesn't know, like, oh, I need to update the save file, or I need to do this and that. So you can iterate and spend a lot of time. So I found you have to be pretty sure, like, what is the feature that you want. Now this is kind of, to that point, which is, if you just start asking Claude to do things, Claude will just do it. And a lot of times you get tired of approving everything. So you just say, like, okay, give Claude the ability to update files, give Claude the ability to do this, to do that. And so pretty soon you say something and Claude's gone through and just gone crazy on all your stuff. And you're like, holy crap. Like, can we is there like an edit undo for Claude? Like, did I freaking create a new branch for this? Probably not, because I hardly ever use Git. So I didn't think ahead. So now it's just, barfed all kinds of stuff. So when you look at Claude Code's page, even they say to break it out to a bunch of files, which I found is not correct. But there are ways that you can talk to Claude to tell it to think about things, to ultra think, to think really hard. Don't make any changes. Come up with a plan first. There's even a mode you can click in Claude, which like kind of puts it in like thinking mode or whatever, as opposed to doing mode. And so I found myself doing this more as the program got bigger. I would say, okay, I'd like to do this. Create a plan, everything, analyze the code. What do we need to do? What's got to change? All this kind of stuff, so that you can then look at how's it going to tackle the problem you ask it to do, and does it look like that's correct? And so, like I say, if you don't know anything about code, hardware, oscilloscopes, you probably can't vibe code this. Like, it's not going to end up working. You're going to get frustrated. But because I know enough about this kind of domain stuff, just not the other piece, this tool seems to work pretty well. Let me check out the chat over here. Oh, amateur radio in England, 73. Okay, and then tracking costs. So when you exit Claude, it will show you how much you spent. And it also does, it clears the context, which is important. So you see down here, it shows I spent 6 cents basically. I did like a Git update or something like that, update my changes with Git. But the cool thing is, as you're doing the stuff, what I found I like to do after I've been using it for a while is I would go into Claude, I would have it create a new branch, I would add the feature I wanted to add, just like as if I was working with a software developer or something like that. We'd add the feature. I would then have it document all the changes, commit it to, do a commit, push it, the whole deal, merge the branch in, whatever, once it was fully working and I had tested it. So I treated it, like you would any software development kind of thing. And then I would exit. which clears the context. I'll get into that a little bit, which is important. And it shows you your cost. So it's kind of cool to look at after a while, like, okay, well, how much did this feature cost me? If you're using the API interface where you're paying for credits, you can be like, okay, that was a $5 feature, that was a $10 feature, going back and forth costs this much or whatever. So I really liked doing that as I got more into it. The question, are you running Claude natively? Well, I'm using Claude code on the command line, is how I'm connecting to it. Now, the other thing is to learn the language of UI if you're building up something with a front end, because you're going to be talking to Claude, and it's just like talking to someone else, a developer or something. If you don't know what the hell you're talking about, and you're like, can you move the box over here or do this or that? Claude's going to have to try to figure out what you actually mean. When you might mean like, can we add a divider bar? Can you add an input field here and this and that? And so knowing kind of the how do you talk about the various elements in the interface and moving them, shifting them, whether they can be resized or not, they're fixed. That stuff makes it vastly quicker to communicate with Claude and get what you're looking for. The same way it would be probably talking to any other developer or anyone else. Like, there's nothing special about it. Like, if you don't know what the hell you're talking about, somebody else doesn't know what the hell you're talking about either. But the cool thing about Claude, I put this picture here because you can actually give it pictures. So when I was first building the interface, I was like, how the hell do I tell it where I want to put stuff? And so I saw you can give it pictures. So I said, okay, I just drew on the iPad real quick. Like, I want my channel data here, my FFT here, this stuff here. Here's my main window. And I gave it to it and it moved it all around. And it put it in that format. It still was kind of janky how the stuff was at the bottom. But that was because I didn't know how to communicate with it properly about what I was trying to do with the UI. But it definitely shifted things the way I wanted. So like if I took a screenshot now of the interface and I drew on it and said, okay, I want to move this over a little bit. I want a slider bar here, and I drew it. It's like, I think it would probably be able to figure it out from that information. So I include this because this was kind of hilarious to me. So when I was choosing the GUI framework that I wanted to use, I didn't really know what to use, and I know there's Qt or Qt, there's TKenter or Tkinter I call it or whatever, and then there's this PySimple GUI, and so I asked Claude, I was like, what do you suggest basically, like which one should I do? Which one should I do? And it said basically PySimple GUI or Tkinter are they're both real good. And it kind of pushed me towards PySimple GUI, and I hadn't used it before, and I like trying stuff that's new. And it said, oh, this thing is like so simple, everybody can use it, and Claude will be able to use it well. It'll just be great. So use that. Okay. So I used PySimple GUI. Now, every time I would start my application after I'd switched to this framework, there's this little pop-up that kept coming up. And it's like, hey, you need to get a code for PySimple GUI. And I was like, okay, like it said it was free or whatever. I asked Claude. Claude said it was free. And so I go to the website and there's a hobbyist, whatever license. All of a sudden it's well, they're not offering the hobbyist license for free anymore. And this isn't a knock on PySimple GUI. Like, they were, it's probably a business for them or something, and so they can't give it away for free anymore. Their price, like every open source thing, they're supporting a bunch of companies that are probably raping them, and so they're like, hey, buddy, we gotta charge for this thing. So it was $99, and I think now maybe they're even shutting this down. It seemed like their messaging changed very quickly over the few days that I was looking at this, and it wasn't very long ago. And I thought, $99, like I'm just playing around with this thing trying to make a tool, like 99, and then is it 99 for just me, or is anybody that downloads this thing's got to pay $99? Like, I was like, I don't want to mess with this. Well, the crazy thing is if you're using Claude, it's like, well, let's just frickin' rip it out and put in something else. So I told Claude, like, hey, we're not doing PySimple GUI anymore. Rip all that crap out, and we're switching to Tkinter. And so it did all of that work. It literally extracted everything out. It told me, like, hey, that's a great idea. We should do that, and it won't be hard. And so it cost $5 in API credits to completely swap out my application from this other GUI framework I'd been working in for quite a while over to Tkinter. And that was also kind of profound to me because it's like, wow, if I had written this program myself, I would have been completely married to PySimple GUI at that point, right? Like $99 is like, it would have felt like shakedown money, but I would have just paid it because at this point, it's like if the tool's working good for me, I just, that's it. My hands are tied. And especially like you look at Glitchy, when I wrote that thing, if they'd been using that after 2 months of development, like hell yeah, I'm paying $99. And now it's like, nope, I'm just ripping the whole thing out and switching to something else. And so it was pretty profound to me of like, these things, when there's various APIs, you're locked in or this or that. It's like the switching costs and those types of business models might get disrupted, because it might turn out it's a lot easier to switch than we think it is. So kind of what did this change about how I think about code or whatever? So it made me think more as opposed to like how do I do the actual stuff, like what's this command called, how should I group this or that. It made me think more about the bigger picture, which I thought about the bigger picture when I was writing Glitchy, obviously, because I was reading about design patterns and things like that. But then you get lost in the weeds of the execution, and it's hard to stay at the bigger picture. And so it just kind of changed what I think. It also let me see the value of proper development using like Git. So if I'm writing the code myself, even though I should use Git and I should be committing things, I should be doing branches, all this stuff. It's like I'm making all the changes to the code and I'm not being an idiot and I'm paying attention to what I'm doing, not most of the time at least. So my discipline wasn't that good. But with Claude, your discipline has to be incredibly good. And probably the same as if you're working on a large development team or whatever, and you just have a bunch of different people in the code. So I noticed that and also I don't have to know any of the crap about Claude, right? Or about Git. I don't have to how do I merge? How do I branch properly? How do I do this, that? I know all of those things. I can write them all down quick on a piece of paper. Here's how I should do it. I should initially create my project. I should create a branch for each one. I should do my commits with all my documentation. I should then push it. Okay, great. I just tell Claude to do that stuff, and it does all the other commands along the way and asks me, okay, do you want to do this? Do you want to actually commit it or whatever? And so I ended up using Git way more while using Claude. One, to kind of guardrail what's happening, and two, because it's pretty awesome when you actually do it, and you create a branch for something and you're working on it. Maybe it just doesn't work the way you think. So, okay, screw it. You get rid of the branch and that's it. Let me check out the comments. Claude is now known as Fiverr. That's awesome. I'm sure, yeah, there's probably a lot of people that are using this that don't know a damn thing about anything. Yeah, and so the last piece is the prompting and following the train of thought. So I did find more and more as I was prompting Claude, I would look at what it had spit out, and then I would stop it maybe partway through and be like, no, that's not how I want to attack this problem, or I don't think that's right, or did you look into this? And so, especially as whatever you're doing gets more complex from just writing a simple script, you do have to pay attention to what it's doing. Welcome our new overlords. So I hear these kinds of arguments all over the place from various different things. You're going to be dependent on it. And this is regardless of what you're doing. It doesn't have to do so much with AI. It's more of a general thing, but you hear it with AI. And so, it's like I wasn't going to be a software developer anyways. Like, I don't give a crap if I'm dependent on AI, because it's only like a net positive for me at this point. I haven't seen a downside. I'm sure the chat might fill up with the downsides, but I haven't seen it. And this is the modern world. We're all dependent on things we don't understand. This might not be completely the case for the people in the chat for Richessum, because you guys might all be mechanics and you work on your cars or you work on things, but most people aren't, and they don't need to be, and they don't even know anything about how the thing functions or anything else. And And I think more and more you don't need to be a programmer to write programs. Like, uh, you can crank out a lot very quickly, depending on what your level of understanding is. But to create very large things for sure. But to create smaller things, stuff that push you a little further than you might have gone before, I think it's going to change things quite a bit. It definitely has for me. Like this tool is like super helpful for me. I've been using it a ton. And like I say, I would have just never even had it before. I would have had to pay somebody to make it, and I would have had to pay them a lot more than I paid Claude in my day and a half, as you'll see when I show you the amount I spent. Somebody said no thanks to the Sneaker movie. Sneakers, that's wild. Sneakers is like one of the best movies of all time. But to each their own, I guess. So the other thing I thought was interesting is when I was chatting with my buddy, and I was like, man, check out, like I wrote this program. I was saying something, and I said, this program that I wrote, and he's like, well, you didn't write that program. And I was like, well, yeah, I guess that's kind of true. Like I didn't technically write that program. And it made me think about like, well, what is it to write a program? What does it mean? Who cares if you wrote a program? Like, not who cares in the sense of who cares, but like who would care? Software developers. That's like some kind of philosophical question for them, probably. But the user of the program. If someone said, "Hey, Ash, you want a signal analyzer program? I saw you had a stream. You said you didn't know how to pull anything from your oscilloscope. You wanted this signal analyzer program that can grab the stuff. It's got a couple bugs, but like it basically works, and you can have it for free." I'd be like, "Hell yeah!" And then I might say like, "Hey, did you make this, or would you get it from somewhere?" But in the end, like I wouldn't really care. So here's 3 programs. They're the most basic you can get. They're Hello World. One of them I wrote. One of them I searched the internet and copy pasted, and one of them Claude wrote. And so, who cares? And 2, does it even matter? So the one I wrote, how was that done? I know I've memorized the print statement for Python because I have to print out so much crap to debug things that I'm working on. So of course I just know it. It's not that hard to memorize. So if someone said, "Hey Ash, can you show me what Python's like?" I could be sure, open it, create a file, print hello world. Then I created a program the way probably a lot of things are done, which is I was like, I went to Google and I said, I need to make a program. I want to create a program in Python that can print something to the screen. And so I ended up on Stack Overflow, Stack Exchange, somewhere with some sample code that's here's. And so I copy and pasted it. That's the second one down there. So I was like, whoop, copy, paste. So did I write that program? I copied and pasted it into there. And then the third one, I opened up Claude and I said, I want to create a program that is basically going to do this. And so here we go. We're going to create Hello World 3 because I'd already done the other 2. And I tell it what I want it to print to the screen. And as I'm typing it, I realize like I better put it exactly how I want it to print to the screen. And so then Claude creates this program. How different is that from me Googling it to copy and pasting it? How different is it from me having memorized the commands to put it out there? So it's like, yep, I'm going to create this file. Here's what's in it. Which kind of took a little longer than I thought, honestly, for something that I figured would have cranked out faster than that. But I exit. This isn't through the API for the paying for the credits. So you don't see the cost for that. That's with my personal Claude account. But then when I run it, here's the output. Like the result is the same. And the same for the signal analyzer or anything else. So personally, I really don't give a crap who wrote it. I care, does it solve the problem I have? And so in this case, it does. Now, what's the cost? So this is my usage over the few days that I was doing it. This tool cost me like about $140 to make. And so the first day you see, the 23rd, I'm kind of starting to play with it. I finally got the API connected or whatever, and I'm sending some commands. The 24th, I'm working with it a little more. I'm kind of figuring out like, well, what can I do with this thing? And then the 26th through the 28th is when I'm really basically creating this kind of this program and going down the rabbit hole with it and everything else. And so that turned into about $140. So for me to create this signal analyzer program that allows me to connect to my oscilloscope, pull the trace data, perform the analysis I want on it, took me a day and a half and $142 or whatever the full total is there. Which in one sense I'm like, God damn, I spent a lot of money on Claude to do this thing. But in the other sense is, who here wants to develop that program for me for $142 in 2 days? Where I give you minimal maybe information and we're sitting going back and forth, back and forth, back and forth. Nobody's doing it, which is why this would never have been made. And this is also with me learning it entirely. So I wasn't clearing the context like I should. Like as I'm writing code and the context is just building up that context window in Claude, I had no clue that it wasn't clearing it or anything. When you're using the normal Claude app, like in the browser, as your chat gets really long, it tells you like, hey, you probably should like start a new chat because like you're chewing through credits like crazy. And that's against your subscription account. This, I'm just paying for credits. So it probably doesn't give a damn, like if I just chew through whatever, right? I mean, realistically, they just make more money. They do tell you on their website you should clear it, and also your results will be better. But after I realized that and I started making the change, I realized I probably could have made this program for a half or a third the cost. So it's like, really, if I was to do this again, maybe it's only 50 or $60 to get the same program in a day or day and a half or whatever it is. And so, yeah, I mean, that's crazy cheap. Like, to enable somebody, to be able to get those kind of results. So, anytime I need a tool, I'll be 100%, doing this. Now, what my buddy Chris said that I was chatting with as I was making this thing is that this won't make you a better software developer, but it will help you develop software. That's coming from him. He is a software developer. I think there's probably like second order effects or whatever you want to call it of the fact that like I will probably create more software because of this tool, but I might write less software. Like, so, in the sense of like, I'm not going to be writing the software myself, but I might have a greater output of software of these tools that help me solve problems that I have that wouldn't have existed before because I just wouldn't have done all the frickin' typing the software. I would have been wandering the neighborhood staring at the birds and the trees. That was kind of the main thing I wanted to share with you here. Let me come over here, and I did want to show you in my GitHub, where it is here. You won't be able to get to it because, like I say, it's private, unless I'm sharing something here I shouldn't, in which case I'm screwed. But one thing I did have Claude do is I kind of looked at this. I looked at it a little during, and then I hadn't seen it after. But I was like, it would be cool to be able to add in other oscilloscopes. So I had Claude basically break it out into like this. It calls it like a factory, some kind of I don't know what you call that, a framework or something, an oscilloscope factory. And then it documented, here's everything you need to add a new oscilloscope in. So if we want to add a Rigol or something else, what are the various methods? What do they do to connect? And also if I wanted to add in another one later, like I have this other kind of older but big and pretty badass Tektronix oscilloscope. So like maybe I want to add that in. And so everything is here that I would need. And then if you look at in the drivers folder, you see the various ones. And like I say, I mean, like I haven't really looked at these, so I don't know, how disgusting they are in the sense of like the actual code that's been written. Let's see. I mean, what's here? List devices. Yeah, so it's got functions for dealing with the stuff that, that it figured out. But like I say, like, I don't know, I'd never even looked at any of this code, right? So it, I would say it did a pretty awesome job. Now you contrast that with glitchy. So here's the one that I wrote. And so it's definitely more concise in what it did. I have this model view controller framework that I broke it out into. Here's the various things that I can control. Here's my power supply and how I talk to it. You can see it's definitely way less documented than the Claude versions. You kind of have to tell Claude like to ease up on the documentation. Sometimes it'll just put a bunch of crap in there. But I don't know. This code could probably be better. I don't know. Like I say, I'm not a developer, but all this works to connect and talk to my power supply, and I wrote it all myself, as opposed to someone else doing it. So that was kind of the main thing I wanted to go over. I'll take a look over here in the chat, and I'll see if there's anything I didn't answer. The URL for my GitHub. My GitHub is bitbanging bytes. Let me see here. I'll copy it real quick and paste it down there in the chat so you can see it. But like I say, you won't see the signal analyzer, but you can grab the file. If you're a Patreon, you can head over there and you can download that and check it out and play with it and do whatever you want to do. One question is, are you using this for your smart meters? I could. I mean, it's like a generic program to help me break into any microchip and extract the memory. So the last video you saw on the channel a while back was on this finding a 0-day vulnerability in a SAM 4C32 chip. That's from a smart meter. Let me see if I have that guy. Yeah, that's from this meter here. It was right here, but I pulled it off obviously to do that attack. So yeah, any chip, it would basically allow me to to look at it, to understand how it works and try to extract its memory. Let's see what's over here. All right, I appreciate you guys joining. I don't think I have anything else to show around that. Definitely, I would say if you're thinking about doing some vibe coding, I would encourage you to do it. Like it's pretty awesome. There is a learning curve with it, and it can kind of screw things up quickly. So you have to learn how to work with it. But it depends to your level of comfort developing software. Like if you already like are a wizard at doing it, then I don't know if these tools, if they add any value. They might not. Like they might literally muddy it. It might be like getting a junior developer where you're like, if we're just writing a quick program, I could just do it myself faster. So it all depends on what your level of something is. Like if someone came to me and said, I have this automated soldering tool that if you set it up in 3 hours, it can connect these 10 wires to this part. I'd be like, dude, I can do that in 30 seconds. Like, unless we're doing a million of these things, like this thing is not going to add any value to me. Yeah. So I didn't want to jump on the vibe coding hype train. But this just actually was something that I did that worked for me. So I didn't really feel like it was hype. So thanks for joining. Hope you have a good weekend. Go try vibe coding something. I'll catch you next time.